how do I know if my digestion was successful? That is a very good question, and the only way to truly really know that is by doing an analysis via ICP, OES, or ICP-MS. So remember what our goal is of any digestion. What we want to do with digestion, and the reason that we're doing it, is because we want to get all of our elements of interest stable in solution. We want to take our matrix, break it down completely with acids, and then once we've completely destroyed the matrix with acid via digestion, then we can go ahead, take that, and put that onto our instrument. So understanding whether or not you have a successful digestion is really going to be more qualitative visually than quantitative on an ICP-MS. The only way to be quantitative is by analyzing it. So indications that you do most likely have a complete and successful digestion is that your samples may be clear and colorless. So the only time where that may not happen is, let's say you're digesting metals and metal alloys, you have a lot of copper or chromium or nickel or iron even, so they may be a bit colored. So that's totally normal. So for many of you, say in the cannabis industry, or those of you who are working with plant material, it's very typical that plant material will have silicates in it. It draws it up from the soil. So it is possible that if you're not analyzing for silicates, you can simply let those settle out. If you do use hydrofluoric acid, that is the only way to get rid of silicates. However, if you're not analyzing for silicon, we let that settle out. Typically what we suggest for the pharmanutra industry or for the cannabis industry, where we don't worry about silicates. And of course, what we want to do is we want to make sure that the temperature that we're using is appropriate to completely break down my sample. Just as an example of what a complete versus incomplete digestion looks like. The sample on the right here, this is clear, and then the one on the left here is incomplete. So the incomplete digestion may typically look yellow. It may also have, as we'll see on the next slide here, so it may be yellow. It may also have some cloudiness or unexplained sediment. So issues of achieving complete digestions. There's quite a few things that can cause issues, but let's look at some of the main ones that typically are the culprits. So it's important to understand the capabilities of what your rotor is, be it you're using the Maxi 24, Maxi 44, or SK15. So you want to make sure that you're using an appropriate sample mass which that rotor can accommodate. If your sample mass is too high, you may not be able to accommodate the pressure generated, which could lead to excessive venting, and therefore you cannot reach your temperature because you're losing pressure. The final digestion temperature may not be hot enough, so you may want to go maybe typically increments of 10 degrees Celsius. You may want to try that. Also, your digestion time may not be long enough. Typically 10 to 15 minutes for a hold is sufficient, but there are occasions you may have to go longer. It's possible that the incorrect acid chemistry is being used. If your acid chemistry is incorrect, it doesn't matter what you do as far as temperature, you're not going to break down that sample. Think of if you take a key and put it into the incorrect lock, no matter how many times you try, you won't be able to unlock it. With the appropriate acids, you'll be able to break everything down. And again, some signs of incomplete digestions are going to be either yellowness due to residual carbon content, or some cloudiness that may be in your sample, or unexplained sediment. Incomplete digestions can cause issues on your ICP or ICP-MS, such as polyatomic interferences at the exact sample mass of your element of interest on an ICP-MS. You can also have suppressions, etc. So you can have some issues there. So we really want to try and get a complete digestion. And I hope you all know if you ever have problems or any of this happens, you can come to us and we can try and help you the best that we can.